Okay, Assalamualaikum and hello to everyone. So in this video, I would like to explain on what I call the uh, index number, okay, and conundrum, okay. Now, as you can see, for the thermodynamic processes, okay, we have five thermodynamic processes. Okay, we have the isochoric, we have the isobaric, okay, isothermal, polytropic, and also the adiabatic process. And for each of these process, okay, for gases, it can be in the form of PV by the power of n equals to C. Okay, so for isochoric, n here can either be, okay, a negative infinity or infinity. For isobaric, n is equals to 0. For isothermal, n is equals to 1. And for polytropic, n can be any number in between infinity and negative infinity, except for the values for the other processes. Okay, so polytropic, n cannot be 0, cannot be 1, and n can not also be the value for adiabatic, where n is equals to gamma or k. Okay, so for each of this process, for gases, it can also be written in the form of PV by the power of n equals to C. Now, what maybe some have a problem, okay, trying to understand what does this do, okay, the value for n. Okay, we have here the PV diagram, okay. Okay, so let's take example for state 1 here. Okay, for an isochoric process, constant volume, the process line for state 2 will go down here. So this line here corresponds to n equals to infinity. Okay. For isobaric, okay, constant pressure, so the process line for state 2 will grow to the right, expansion process. Okay, so this one corresponds to n equals to 0. And then we have the isothermal. Okay, so isothermal process is a curved line. So we have a curved line here in the middle. Okay, somewhere in the middle. And this for state 2. Okay, for state 2 here. And n equals to 1. Okay, so as you can see, isobaric, n equals to 0. Isochoric, n equals to infinity. Isothermal, n equals to 1. Okay, so for polytropic, n can either be in between any number, okay, between negative infinity or infinity. So if n, let's say n equals to 0.8. So the process line for the polytropic, since n is 0.8, will be in between n equals to 1 and n equals to 0. So somewhere maybe here. So this is the process line for a polytropic process with index number 0.8. Let's say the polytropic process, the index number is greater than 1, say 1.7. So 1.7 is between 1 and infinity. So the process line for the polytropic process for n equals to 1.7 is somewhere between 1 and infinity. Okay, so for an adiabatic process, okay, so n is equals to the value for specific heat ratio, gamma. So let's say that we take air, for example. So air, the gamma is 1.4. So 1.4 is in between 1 and infinity. So let's say for an adiabatic process, the process line. So here is gamma equals to 1.4. Okay, so this is how we draw the process line in terms of the index number. Okay, so be careful. Okay, it has to depend on the process. Okay. For another example, let's say we have a PV diagram here and we look at a compression process. Okay, for a compression process. So for compression process, the state 1 will be at a higher volume. Okay, a higher volume, V1, sorry. Okay, and when we compress, the volume will be reduced. So from state 1 for isobaric process, this is state 2. So the volume has reduced to V2. Constant pressure process. So this is N equals to 0. For isobaric process, constant, alright, increase in pressure, compression process. Okay. Here N equals to infinity. For isothermal process, okay, say here, alright, N equals to 1, isothermal process. So it is still the same. Okay, so if the polytropic index is N equals to 0.5, so it will be somewhere here. Okay, polytropic process. For adiabatic process, let's say the adiabatic index for air 1.4, in between 1 and infinity. So here. Okay, so here is N equals to gamma equals to 1.4. So we have to look at the type of process, okay, compression, expansion, and of course the value for N, so we can draw the process line correctly. Okay, so I hope that by showing you an explanation on this, what I call the N conundrum, okay, masalah kepada nilai N ni, okay, so it's a bit clearer, but still if there are any questions you can ask.